Hello and welcome to the 8th in our series of Oxford Archaeology research seminars in which we will be discussing the development of the factory. The seminar will focus on some of the historic factories and other industrial buildings that our Lancaster and Oxford office have recorded over the years. We'll be looking at structures from a number of different periods, including Lancashire cotton mills from the early industrial period, a late 19th century power station in Oxford, and lastly, an example of a particular type of early 20th structure called the Daylight Factory. So in our first presentation, we'll hear from Richard Gregory at our Lancaster office, who will be discussing the Lancashire textile mill. This presentation will focus on the development of the region's early cotton mills, which date to the late 18th and earlier part of the 19th centuries. In particular, he will look at OA's research into the early cotton mill in Manchester, which kick-started the town's transformation into Cottonopolis, the preeminent centre of cotton spinning in 19th century England. Deirdre Forde, in our Oxford office, will then discuss the development of Osney Power Station in Oxford. Dating to 1892, Osney Power Station provides a relatively early example of electricity production for public consumption. Deirdre will explore its construction history and will look at how the evolution of the building reflects wider advances in both energy technology and in industrial architecture. Finally, John Gill, also from our Oxford office, will discuss the development of the Daylight Factory in Britain in the early 20th century. In particular, he will draw on OA's research into the fantastically named Honey Monster Factory in Southall. Daylight factories were pioneered in the United States and began to be constructed in Britain immediately before the First World War. The Honey Monster Factory was constructed relatively late, dating from the 1930s, but provides a good example of this type of industrial architecture. Our three presenters will then be joined to discuss the sites and the questions they raise by Julian Munby, formerly Head of Buildings Archaeology at Oxford Archaeology, who will chair the panel, and Ian Miller of Greater Manchester Archaeological Advisory Service, and formerly a Senior Project Manager at OA, where he specialised in industrial archaeology with an emphasis on the textile mills of Lancashire. They will be discussing the themes raised by the talks in more detail, so please do send in your questions during the seminar via the Q&A function, and they will do their best to answer them. But first, I'll hand over to Richard Gregory to talk about Tales from Cottonopolis, the development of Lancashire's early cotton mills. Richard.
Hello, my name's Richard Gregory and I'm Head of Post-Excavation at Oxford Archaeology's Lancaster office. It's with great pleasure that I've been asked to start this research seminar on the development of factories by discussing a highly iconic factory that OA's Lancaster's office have spent the last few decades and many thousands of hours recording and researching. This is what can be broadly called the Lancashire cotton mill, which in northwest England is still the most graphic component of what is commonly called the Industrial Revolution. This revolution was at its most dynamic during the late 18th and early 19th centuries, which is a period that I'll be focusing on for this presentation, with a particular emphasis on one urban centre, Manchester, which was fundamental to the development of the early mill and the manufacture of cotton goods more generally, and that during the 19th century was nicknamed Cottonopolis, referring to its position at the centre of the country's, as well as arguably the world's, cotton industry. So at OA, we've recorded both the extant remains of these cotton mills during building surveys, and we've also used archaeological excavation to record their below ground remains in the cases where mill buildings have been demolished and levelled. In some cases, it's also been possible to use both techniques, which has actually proved to be highly successful and informative. Now, much of what I'm going to talk about today is encapsulated in several key publications that OA have produced over the years, which include The Textile Mills of Lancashire, based on a survey funded by Historic England, designed to assess the survival of and the threats to Lancashire's textile mills, and also to show how these buildings can be adapted for modern use. Another important publication is A&G Murray and the Cotton Mills of Ancoats, which details the results of building survey and excavation at one of the country's most important early steam-powered cotton mills, which was established in the centre of Manchester in Ancoats. We've also produced several popular booklets produced as part of the Greater Manchester Past Revealed series, detailing excavation work completed on cotton mills in this area, such as a highly important cotton mill that was excavated at Shude Hill, again in the centre of Manchester, with the results appearing in Hell Upon Earth. It's worth stressing that whilst I personally had a small hand in authoring parts of and bringing together the textile mills of Lancashire, and some of the Greater Manchester Past Revealed series booklets, most of this work, and also the work contributing to the other publications, was down to a very dedicated team of OA industrial archaeology specialists, which included Ian Miller and Chris Wilde, two former members of OA, and Graham Mottershead, who now works as a project manager at the Lancaster office. Naturally then, I'm really pleased that Ian Miller can join us today as a panel member, as he has very extensive and, dare I say, unrivalled knowledge and experience of recording textile mills, particularly in Greater Manchester and Lancashire. So, thank you, Ian, for agreeing to be here today. I suppose the first question you might ask, though, is what is an early Lancashire cotton mill? Well, at one level, there's quite a straightforward answer to this, implicit in the terms we use to describe these buildings. So consider this in relation to the mills that existed in the late 18th and early half of the 19th century. It is now clear from excavation, building survey and documentary research that there are three main types of early cotton mill. The first of these is the cotton spinning mill, and significantly, this represents the earliest form of cotton mill, which first emerged in the late 18th century. Now, some of the earliest examples were water-powered, though they quickly adopted steam power as an alternative power source in the late 18th century. Although their now iconic multi-storied design was ultimately derived from early 18th century silk mills, the first true expression of the cotton spinning mill was developed by Richard Arkwright in the 1770s at Cromford, Derbyshire, following his development of a water-powered cotton spinning machine known as the water frame and a mechanised carding engine, which he successfully integrated into the world's first purpose-built multi-storied cotton spinning mill. Steam power was really fundamental to the spread and uptake of cotton spinning mills in urban areas, as it meant that locationally the mills could be moved away from rivers. It eventually allowed for the adoption of beam engines, which had a great influence on productivity and also the appearance of the mill. Specifically, once adopted, the steam-powered plant, the engine and the boilers, were housed either internally in the mill or attached externally, and were served by a tall chimney, which for many people forms the most recognisable and distinguishing element of the cotton spinning mill, as well as being seared into people's view of industrialised areas in northwest England. Now, spinning technology used within the spinning mill was initially dependent on the water frame, which was then adapted as the throstle. There was also a second type of late 18th century spinning machine, the spinning mule, which again was adapted in the early 19th century so that it could be entirely driven by steam power, which is a highly important advance. Now, the adoption of the self-acting mule also led to the development of large urban mills, such as Brunswick Mill in Manchester, with U or L-shaped plans, which could house traversely orientated spinning machines. Other architectural developments related to fireproofing, leading to the emergence of fireproof spinning mills in Lancashire in the early 19th century, containing cast iron columns and brick vaulted ceilings. The second type of cotton mill was the weaving mill, and these were a later development which appeared in the 1820s following the wide adoption of the power loom, which was a steam-powered machine. Now, prior to this, weaving was undertaken using hand looms in weavers' cottages, and once the process had been fully mechanised, this resulted in a rapid and rather painful decline in this traditional industry. Power looms, however, they were heavy pieces of vibrating machinery, and hence they couldn't be integrated into pre-existing spinning mills. And this led to the development of single-storied weaving sheds to house these machines, with characteristic glazed sawtooth roofs to provide the even natural light required for weaving. Architecturally, these were even more utilitarian than cotton spinning mills, as they lacked any architectural embellishment. The third type of cotton mill is termed the integrated mill, which combines both spinning and weaving in one complex. Hence, these contain both a multi-storied spinning block and weaving sheds. And again, they emerged in the early 19th century. So that's some broad classifications of what an early Lancashire cotton mill is, covering three categories, really based on what each of these different types of cotton mill were designed to produce, i.e. cotton yarn in a spinning mill, cloth in a weaving mill, or both yarn and cloth in an integrated mill. We can, however, look at the early cotton mill from a slightly different point of view, specifically through a red-tinted economic lens, and see the textile mill as something quite different. If we do this, we strip away the disguise of a definition determined by production, and it's possible to arrive at the conclusion that the primary function of the early mill was not really to produce cotton goods, but was instead to create what Karl Marx called surplus value, or profit, and concentrate this into the pockets of a few individuals, in this case the emerging class of Lancashire mill owners. From the perspective of creating surplus value, the mills suddenly seem to be highly consumptive entities which draw on and manipulate both labour and technology and absorb raw materials, including, following the adoption of steam power, fossil fuels. Now, there are, of course, some two-way processes, but overall the mills consume and take for profit much more than they give back. Importantly, the textile mill also creates circumstances which allow for the concentration of the labour force into specific areas, which ultimately leads to the rise of industrialised urban cores and suburbs. They also unfortunately produce what I like to call environments of suffering, which include the use of raw materials, cotton, procured through slave labour, and in the mills themselves, the use of child labour and labour that has effectively been acquired through human trafficking, involving the press ganging of some rural communities by fleshmongers, as they were known in the early 19th century. They also promote densely packed areas of workers' housing, where the people in the mill lived, and these were associated with slum living conditions. Now, one area of northwest England where many of these economic processes first occurred and were in many ways amplified and taken to their extremes was Manchester, or Cottonopolis, which became the preeminent centre for cotton spinning and also one of the world's first truly industrialised cities. Now, fortunately, over the last couple of decades, Manchester has been undergoing an urban renaissance involving mass redevelopment, which has allowed the archaeology of many of the early cotton mills and also the workers' houses, so the things associated with the first sugar rush of capitalism, to be studied and recorded. In this sense, excavation and building survey allows us to stare into the cash registers and the business strategies of Manchester's early capitalists. And in terms of mills, it's proved particularly useful for understanding how technology was actively manipulated by them in the pursuit of surplus value. Now, one good example of this can be seen at Shude Hill Mill in the northern part of the city of Manchester, which was established in the early 1780s by Richard Arkwright, the prime early capitalist mover and shaker in early cotton spinning mills. Now, the entire footprint of this important mill was excavated and subjected to detailed historical buildings research by a team from OA led by Ian Miller in 2014 to 15, when its site was redeveloped by the Co-op. Although it had been destroyed in 1940 when it was created, it formed the largest mill that had been built by Arkwright. Now, one other feature that set it apart from Arkwright's earlier textile mills was that this mill was not built next to a river which could power a water wheel. Instead, we see how early steam-powered technology was manipulated and adapted across the late 18th and early 19th centuries to make this mill a functioning capitalist entity. Moreover, this is a very dynamic process involving various stages, some of which could be detected and elaborated through the excavation of the mill's surviving remains. So stage one in the manipulation of technology was conceptual and dates to 1780. With Arkwright's initial plan was to use a pumping engine to pump water onto a water wheel from an adjacent reservoir to power the spinning machinery in the mill. So this was an indirect way of using steam and was also an arrangement that Arkwright had just applied in 1780 at another of his mills in Derbyshire. We then, however, move into an innovative stage, as during the construction of the mill, Arkwright was persuaded instead to buy an atmospheric engine from Thomas Hunt, provisioned with a crank and a flywheel, which therefore could in theory produce rotary motion to directly power the mill machinery. This engine was installed in the mill in 1781, and at the time it was fairly revolutionary, although it was clearly not up to the job and it failed to work. Based on this failure, Arkwright then enters into a conservative stage in 1782, whereby he decides to revert back to Plan A and install a steam engine to pump water onto a water wheel. Now, excavation at the mill, together with documentary research, provided further details. The water wheel pit, housing a 8.5 metre diameter water wheel, was excavated, which was found to be inside the mill against its eastern wall. The position of the water wheel axle could also be seen, and it was also apparent that water was fed into the base of the wheel pit from a nearby reservoir through arched culverts, and from there it was pumped up through pump barrels and then flowed onto the top of the overshot water wheel. The next stage in the manipulation of steam technology came in 1791 and represents a phase of imitation and replacement. This was almost certainly influenced by the fact that another Manchester mill owner, Peter Drinkwater, had installed a Boulton and Watt rotative steam engine in his Piccadilly mill in 1789, which represents Manchester's first cotton mill to be powered entirely by steam. By this stage, however, Arkwright no longer owned the Shude Hill mill, and there this imitation was undertaken by its new owners, the Simpsons, who installed a similar Boulton and Watt steam engine into their newly erected Miller Street mill in 1791, which now formed an additional element to the Shude Hill mill complex. Once this proved successful, this was followed by them making an order for a second larger Bolton and Watt engine to replace the pumping engine and water wheel in the Shude Hill mill, which by this stage was falling into disrepair. This engine was installed and working by 1793. Now, the excavations at the site exposed elements of this replacement power system, comprising brick-built footings for 2 wagon boilers and the walls of the adjacent engine house, with a central wall that supported the beam engine. The final stage in the manipulation of steam technology represents a phase of improvement by the Simpsons in order to increase the mill complex's potential to create surplus value. This initially entailed the replacement of larger engines in both the Miller Street mill and Shude Hill mill, with an improved and more powerful Bolton and Watt engine, entirely constructed in cast iron. At the Shude Hill mill, this required the construction of a new engine house, which was recorded by the excavation, which was partly built in stone. Although it was apparent that many of the original elements had been removed in the mid-19th century. The footings for 3 boilers raising the steam for this engine were also recorded, which were again wagon boilers, an early type of boiler. I'd like to bring this to an end, but I'm hoping that I've highlighted in some way why Lancashire's, and particularly Manchester's, groundbreaking cotton spinning mills are important, as not only do they represent the archetype early factory, but they're also one of the key pieces which kick-started, moulded and set the ground rules for the capitalist factory-based system of production, which still holds sway today. Archaeological analysis and recording of these buildings adds another element to our understanding of these processes, particularly how emerging technology was rapidly adopted and manipulated to ultimately increase the mill's productivity, as hopefully I've shown with the example of the Shude Hill mill. Now, perhaps worryingly, many of the themes that the mills invented and set in motion regarding the manipulation of technology and labour, consumption of fossil fuels, and creating what I've called environments of suffering, as well as the mass production of consumable goods, all as a means of ultimately creating surplus value, still seem highly pertinent today. In fact, we're still wrestling and negotiating with this capitalist legacy and all of its associated traits. It's also worth noting that in Manchester at least, many of the surviving mills, particularly in the Ancoats area, have been successfully adapted for modern city life, being converted into apartments and commercial spaces. And so, ironically, in economic terms, their primary function is still retained and flows again through the fabric of these buildings as they continue to fulfil their primary function, which is to accumulate surplus value. Okay, thank you very much.
Dating to 1892, the site of Osney Power Station, while not an actual factory building, is a relatively early example of an industrial building for the purposes of electricity production for public supply. As demand for supply increased exponentially over the following decades, so did the power station in both size and productivity. This presentation explores its construction history and how the fast evolution of its phasing coincided with the wider advances of both energy technology and industrial architecture. A number of towns and cities began providing public electricity in the early 1880s, following a number of breakthroughs in electrical technology during the 1870s. The first public supply in Britain was Godalming in 1881, using a watermill to generate power to street lamps. This was not successful, however, and the generators were replaced with traction engines in 1882, again with limited success. The mill was closed in 1884 and public electricity didn't return to Godalming until 1904. In 1882, the English Edison Company opened a generating station in London at Holborn Viaduct, supplying 1,000 lamps with reciprocating steam engines, but again it failed within a few years. A more successful undertaking was that in Brighton, which also began in 1882 using the brush electric arc lighting system, and after 5 years the supply, which had previously just been in the evening, was expanded to day and night. In 1890, an electric lighting order was granted by Parliament for the establishment of a public electricity supply in Oxford, and in August 1891 the Oxford Electric Company was registered, with a capital of £100,000 to carry this through. Designed by Mr. Brevet of Wolverhampton, Osney Power Station was built in 1892 by Messrs. Kingerly. The site was chosen at this time at the banks of the Thames at Osney so that the operation was kept away from the better parts of town. The river ensured that there was a constant supply of water for cooling, while also providing a means of transport for coal deliveries by boat. It was, however, in a very residential area, and the 1899 OS map shows the footprint of the early power station and terraced housing along the east boundary. With its location so close to town, the Oxford Electric Company was keen to convey the wonders of electricity production at Osney and its potential to the Oxford public with a grand opening. This was held on the 18th of June 1892. The flyer advertises dinner, short trips on the river, a performance by Herr Slapowski's band, an exhibition of heating and cooking apparatus. These included electric saucepans, kettles, curling tongs, office heaters, electric lighters and electric motors. The current was officially switched on by the Lord Mayor at dusk. The new station inspired a poem by Hilaire Belloc, an Anglo-French writer and historian and noted president of the Oxford Union. Descend, O Muse, from thy divine abode to Osney on the Seven Bridges road, for under Osney's solitary shade the bulk of electric light is made. Hence are the works, from hence the current flows, which, so the company's prospectus goes, can furnish to subscribers hour by hour no less than 16,000 candle power. The new power station used steam-driven turbines fueled by coal. The system was that of high-tension continuous currents with dynamotors or current transformers, which produce currents of low pressure. This was used to pioneer a system for transporting energy through the network, which became known as the Oxford system. An article in the Engineer magazine dating to its opening in 1892 describes how the plant was kept on the first floor, and the engines and dynamos were separated by a wall from the boilers, also on the first floor. A photo showing the original first floor of the station shows the dynamotors, another plant. Oxford wasn't the first town to establish a public electricity supply such as this, but on a national level the construction of this facility was relatively early. In the beginning, the station supplied streetlights, colleges and public buildings, but thereafter it was increasingly used for households, and demands for supply consequently increased. Therefore, the size of the station had to increase, and so did its productivity. The northern extension, designed by Herbert Quinton, was added between 1904 and 1905. A gable structure was built on the north side that mirrored the primary gables overlooking the river perfectly, as well as a further range with 3 north gables and hipped bays at the east and west ends. In the northwest of the extension, overlooking the river and overlooking its coal deliveries, is the eye-catching oriel window of the engineer's office. In 1925, it was modernised with new boilers and steam turbines. It underwent significant redevelopment, and the enormous red brick and sheet metal buildings that exist along Russell Street were built at this time, necessitating the demolition of the terraced housing along the east boundary. The station was developed again in 1927, and the buildings on the southwest corner of the complex were added, and these can be seen on the right-hand side of the photograph just under the tree branches with the sheet metal. After the corporation took over operations of the station in 1930, a further building was added on the west side overlooking the river, and that can be seen just on the right-hand side, just on the south side of the primary gabled elevations. Quite a pretty little Art Deco elevation. The fine quality proposals for both of these phases survive in the collection at Oxford Town Hall. Although at the time planning permission wasn't strictly necessary for the huge expansion of the building, detailed plans of the utilities and inner workings of the building were presented to the corporation for approval. 1930 marked the end of the expansion of the building, and in 1963 the power station underwent a conversion to oil firing, and its role was reduced to supplying the national network with power at times of peak demand, which mainly occurred during the winter months. Peak lopping is the term used to describe the generating plant used during the peak demand periods. Electrical power was taken by the city distribution substation at Ferry Hinksey Road, which supplied power from the national grid to the Oxford area when the station was not generating. The station closed in 1969 and supply to Oxford was taken over by Didcot Power Station. The engineering department at Oxford University took over the building in the 1970s, and it was used for hypersonic research until 2010. There was still evidence of this use in the interior at the time of survey, most notably in the form of the huge hypersonic wind tunnel with 2 turbines at the south end. Photographic evidence of its installation in 1973 was found in the archives at Oxford University's Department of Engineering Science, as well as the tunnel itself under construction. During this period, the footprint of the station remained unchanged, but the interior was subject to some development. The presence of building materials in the second photo is evidence of the internal subdivision for labs at the south end of the station by the department. In 2017, Oxford Archaeology was commissioned to carry out a Level 3 archaeological survey and impact assessment prior to the station's redevelopment. Plans and elevations were provided by Ridge Architects, and these were annotated and phased, and a detailed photographic survey was carried out on the exterior and interior of the building. Through historical research and investigation of the building itself, 6 phases were identified. The primary phase in red, dating to 1892, the secondary phase in orange, dating to 1904 to 1905, the third phase in yellow, dating to 1925, the fourth phase in blue, dating to 1927, the fifth phase in green, dating to 1930, and a smaller 20th century structure in grey. The inside spaces were divided. The first phase into 1A and 1B, those of the second phase into 2A and 2B, and so on. This was for the ease of description in the text and for cross-referencing between text, the drawings and the photographs, as well as for interpretation of the sequence of construction, function of spaces, and a spatial relationship between different elements and different phases. Phase 1 is most notably represented by its highly ornate gable elevations facing the river, which can be seen to be influenced by John Ruskin, a leading 19th century art and architecture critic, who also influenced the design of the Museum of Natural History in Oxford. The design of the buildings, with elaborate polychromatic brick detailing, reflects a pride and concern with aesthetics that is a strong feature in many 19th century industrial buildings of this type. Water inlets can be viewed in the plinth of the gables above the level of the river, which would have been used for steam engines and cooling. It is unclear how much of the east ends of the roof structures, if any, were truncated by the third phase of construction. The generating plant has been removed, but on the floor where the reciprocating steam engines would have been located, there are 3 overhead gantry cranes which would have been used to install them and to move planter machinery within these areas. They can be seen in the photograph from 1892. Each crane would have been operated manually by means of cogs and wheels with a pulley chain. They would have been moved laterally north to south between bays and transversely east to west along rolled steel joists supporting the lifting equipment. The ground level of the primary phase is a space divided with large concrete pillars that support the first floor. In places, these can be seen to be built around original steel uprights. These seem to have been inserted as additional support and indicate a need for increased load bearing in the 20th century. Between 1904 and 1905, the second phase was built. The river-facing gabled element was built to be identical to those of the primary phase. The linear range on the north side with the oriel window overlooking the river and the row of 3 simpler gabled structures were sympathetic architecturally to the primary phases, but reflect an updated style in industrial architecture. This northern range appeared to function as a service area with kitchen WCs and showers on the ground floor and administrative offices on the first floor. And in the upper right hand corner you can see the engineer's office with the pretty oriel window in the west side. This northern extension retained some of its original interior detailing, such as window furniture and parquet flooring, which is probably original. And a lot of the partitions along this side in the offices used tongue and groove panelling, which also appears to be primary. The third phase was built in 1925, necessitating the demolition of the terraced housing along Arthur Street as the power station expanded fully into the footprint of the site from east to west. The whole complex was built of red brick and corrugated sheet metal and is characterised by its huge eastern windows and minimal architectural detailing. The defining character of the west elevations is their sheer size and impressively large windows, defining the interior as functional spaces needing to be flooded with daylight. But the early 20th century character comes through in subtle decorative effect, such as the slightly recess of the bays and wide modernist style windows on the North Range. The enlarged power station was modernised with the addition of 6 steam turbines. These parts of the building mainly constitute large open plan areas where the turbines would have been located. These are now gone, but the hopper or silo frames which would have fed coal to the boilers are still in place, as seen on the right-hand side of the upper right photo. In the lower left photo, the huge overhead gantry crane used to move plant can be seen in situ. This is made up of 2 north to south fish belly running girders with chains and pulleys that could roll along east to west running girders. Phase 4 was built in 1927 and the plans in Oxford Town Hall show that this would have been built to accommodate a coal bunker. At the time of survey, this area was divided into 2 levels and its ground floor was being used as a storage facility for Oxford Museum of History of Science. Phase 5 was built in 1930 and architecturally it is reminiscent of the Art Deco buildings dating to this time. It was designed to complement the original building, somewhat matching its scale. It also makes use of the polychromatic brick detailing, albeit using a different design. At the time of survey, the interior was largely taken up with collections owned by the Pitt Rivers Museum. Its use by the engineering department was very much evident on the interior at the time of survey. The plan of the power station on the right-hand side from an earlier statement of significance shows the sheer size of the wind tunnel built into the power station. It was held up with a robust steel frame and was built mainly of plastic, plywood and other modern materials. It could be entered through a lab on its east side, and the twin jet engines could be observed in its south end. This low-density wind tunnel was essentially the sole tunnel of its kind then operational in the UK. An example of research done in it is the work performed for NASA on measurement of drag on the Mars Pathfinder probe. To read directly from the website for Osney Lab, which is still up, the vehicle model was tested by suspending it magnetically in a Mach 6 low-density flow, and the data obtained compared well to that derived from the flight trajectory by NASA as the probe decelerated in the Martian atmosphere. This is the most significant feature of the station's most recent past, but prefabricated labs, platforms and offices associated with the experiments are also built into almost every part of the 1925 power station. In conclusion, Osney Power Station is significant for its integral role in the development of energy for public consumption in Oxford, as well as at a more national level in the pioneering of innovative systems of transporting energy through the network. It demonstrates the development of industrial architecture, both in size and form, to contain the plant and technology involved in the evolution of energy production in the late 19th and early 20th centuries. Osney Power Station would be typical of other power stations that were developing around the country at this time, but it is conspicuous by its size and its location in a residential area adjacent to Oxford city centre, all of which make it desirable for redevelopment today. And now I'll hand you over to John Gill, who is going to talk about the development of daylight factory buildings in the 20th century. Thank you.
In this paper, I will discuss a particular type of industrial building known as the daylight factory, which emerged in the first decade of the 20th century and was influential both in industrial architecture and the modern movement more widely. I will then go on to talk about the Quaker Oats factory, otherwise known as the Honey Monster factory, which Oxford Archaeology recorded in 2019 and which provides a good example of this type of complex. The daylight factory comprised a multi-storey building with a reinforced concrete frame and a non-load-bearing curtain wall to the exterior, with extensive glazing to ensure plentiful natural light. These plants were carefully planned to maximize efficiency and to use gravity in the manufacturing process. The origins of this type of structure lie in constructional developments in the later 19th century, particularly advances in the use of reinforced concrete in both America and continental Europe. One individual of particular note in this period was the French engineer François Hennebique, who developed a constructional system using reinforced concrete posts and beams with separate elements integrated into a monolithic frame. Hennebique patented his system in 1892, and in the UK it was promoted from 1897 by the engineer Louis Mugel. The earliest large reinforced concrete building constructed in Britain is thought to have been Weaver's Mill in Swansea, built in 1897, but sadly it was demolished in 1984, and the earliest surviving large building using the Hennebique system is probably the CWS warehouse on the quayside in Newcastle. This was constructed between 1897 and 1900, and it is now the Malmaison Hotel. Another very important figure in the field of early reinforced concrete framing was the pioneering architect Ernest Ransome, an engineer working in America. In 1903, he constructed what is generally considered to be the world's first daylight factory, forming part of the Pacific Coast Borax Company's site in New Jersey. Although Hennebique's and Ransome's systems were of significance in the development of reinforced concrete, the principles of their constructions were similar to those of timber and iron framing, with floor loads passed to beam and then to post. They did not fully explore the versatility of reinforced concrete as a constructional material. This was to change in the following years during a period of rapid innovation in the first decade of the 20th century. Among the key innovations in relation to the daylight factory was the use of columns with distinctive flared mushroom-shaped heads, which removed the need to have conventional beams or downstands to support floor slabs. Such columns allowed the underside of the floor slabs to be flat between the columns so that pipes, ducts and services could pass around a building unobstructed. The system also allowed for even larger expanses of glazing to the non-load-bearing external shell. The so-called flat slab or beamless construction was developed by several individuals, again on both sides of the Atlantic, including Claude Turner in America and the Swiss engineer Robert Maillart. This innovation led to the relatively brief heyday of the daylight factory, lasting roughly from 1906 until the outbreak of the First World War in 1914. Several new companies began offering flat slab construction systems, with one particularly significant one called Truscon, shortened from the Trust Concrete Steel Company. Truscon was established in 1903 in Michigan by the influential architect Albert Kahn. Together with his brother Julius, and hundreds of buildings were constructed in America using this system. Albert Kahn is particularly notable for numerous car factories, including those that he designed for Henry Ford at his seminal car factory at Highland Park, Michigan, between 1908 and 1910. These factories were highly innovative, not just in terms of their multi-story daylight factories, but also for their use of specialized assembly line production. A London subsidiary of Truscon was formed in 1906, promoting the Kahn system of reinforcement, but the adoption of flat slab construction into Britain was slower and less widespread than in America. Several buildings using the new system were constructed in Britain immediately before the First World War, including the clay printing works in Southwark, 1909, the Ford car plant in Trafford Park, Manchester, 1911, a Harrods building at Barnes in 1912, and 2 buildings in Scotland, the Arrol Johnson car plant in Dumfries, 1912 to 1913, and the John Burnet and Sons Institute in Glasgow. The constructional advances which the Daylight Factory and the flat slab represented were primarily driven by industrial needs, the desire to make production as efficient as possible, but they also proved highly influential on young architects such as Le Corbusier and the modern movement more generally. In particular, Le Corbusier's modular domino house from 1915 had a reinforced concrete frame at its core and the flexibility of non-load-bearing external walls. By 1920, Truscon said that 90% of the multi-storey factories in Britain were of reinforced concrete construction. However, by this point, the high point of the Daylight Factory, at least as an innovative architectural movement, was over. Many were still constructed in the interwar period, but the need for natural light was less pressing due to electric lighting, and it was becoming apparent that for many industrial processes, multi-storey buildings were less flexible than large single-storey sheds. In the 1920s and 1930s, other types of factory were becoming more common, such as the so-called bypass factory, with relatively low manufacturing sheds to the rear behind a prominent office range, often highly decorative, facing onto an arterial road. One much-loved example of this is the Grade 2 star listed Hoover building, opened in 1933, facing onto the A40 on the west side of London. This was designed by Thomas Wallace of the important architectural practice Wallace, Gilbert and Partners, who also constructed a series of other Art Deco factories on the arterial roads to the west side of London between about 1927 and 1935. The Hoover building is now justifiably celebrated, but the architectural critic Nicholas Pevsner said that it was perhaps the most offensive of the modernistic atrocities along this road. These new factories were intended to form a sharp contrast with the classic image of the dark satanic mills of the 19th century, imposing red brick buildings with steam engines and tall chimneys belching smoke. The new factories were intended to look modern, clean and efficient. They were American in inspiration, electric powered, and they generally manufactured consumer goods rather than traditional heavy industrial products. The Quaker Oats factory, otherwise known as the Honey Monster factory, was a manufacturing complex in Southall, West London, which Oxford Archaeology recorded in 2019 prior to its demolition. This provides a good example of a daylight factory. As previously mentioned, daylight factories continued to be constructed through the interwar period, and the Honey Monster factory is illustrative of this, forming a very late example of the type. The earliest section of the factory was constructed in 1936, so it would have been seen as having a very conservative design at a time when other manufacturing plants were more likely to be large single-storey sheds with a prominent range to the front. The external character of the complex is austere, with very little in the way of decoration, and this is particularly surprising for a national market product such as this, where architecture could be used as advertising. The concrete frame is visible to the exterior, and there is extensive glazing, although not full curtain glazing as at some sites. It also incorporates panels of non-load-bearing brickwork. The overall form and character of the factory may have been dictated by the Quaker Oats Company, as the design closely followed the company's older plants in America, in Iowa and Missouri. Indeed, it could be said to follow something of a Quaker Oats house style. The fact that Quaker Oats was an American company reflects an important feature in this period. American companies establishing modern factories in Britain, particularly producing food products and consumer goods. It may be that this type of manufacture was still well suited to the multi-storey factory, but it is interesting to take note of the shredded wheat factory in Welwyn Garden City, where the product had been produced in a classic Truscon daylight factory since 1925, but here production was moved to a single-storey shed in 1939. The Quaker Oats complex in Southall had a T-shaped plan incorporating a 10-storey main mill where the processing was undertaken and a lower adjoining block with office space and warehouse facilities. The site was located adjacent to the Grand Union Canal as well as to a branch railway line. each of which were used for distribution. There was a covered wharf immediately adjacent to the building for transshipment from the canal and facilities for the loading and unloading from the railway. The end two bays of the lower range were open at ground floor level to allow trains to pass through for covered loading from the adjacent dispatch area. The factory was clearly intended to be enlarged from the outset, and the mill was raised in height in 1938, just 2 years after its original construction. Numerous further phases of expansion were undertaken in the 1950s, most of which followed the same basic constructional form. Our understanding of the growth of the factory was considerably enhanced by a set of photographs which were contained in an album found on site. Among the photos were ones of the complex under construction, as you can see here, or in the early phases when only parts of the ranges had been built. A large grain silo was constructed in the early 1950s, 1952 to 1954, and then a second silo was added in 1956. These were originally separate from the main mill, although aligned with it, and then in 1957 the mill was extended to connect with the silos. This created one huge main range. It is interesting to note that prior to 1954, when the first silo was added, the site appears to have coped without a grain silo at all, presumably relying on a regular flow of grain supplies which went straight into the mill. From its outset, the site produced Quaker oats, and from 1957 it began production of sugar puffs. These were rebranded Honey Monster Puffs in 2014 due to the unhealthy associations with sugar. The site also produced various dry pet foods, including a dog food called Fullopep from 1957, and then others in the 1960s and 1970s. The factory buildings had the classic structural form of a daylight factory, that is, a reinforced concrete frame with a regular grid of octagonal columns with mushroom-shaped heads supporting flat slab floors. The columns in the basement and ground floor were very large. Those at ground floor were 80 centimetres in diameter, but they diminished in size at each floor level, so that those at the top of the mill were relatively slender. Those around the edge of the building were square in section, and similar square section columns were also found in several places on the upper floors, such as in the image here on the right. These provide evidence of the growth of the factory, as they indicate where the range formerly ended before the building was expanded. Due to the nature of the construction, the end wall could be dismantled to allow the interior to be enlarged relatively seamlessly. The overall structure was immensely strong, and the internal layout relatively flexible. The main floors of the mill were largely open plan, with processing and packaging on most of the floors, with storage in the basement and the ground floor given over to dispatch. Some of the floors incorporated small offices off the processing areas. At one corner of the main mill there was a full-height staircase, a secondary addition, and within the older areas there was another set of stairs and a goods lift. Grain or other foodstuffs arrived at site, initially via the canal wharf, and it was carried vertically up through the building by various simple chutes with scoops enclosed within a duct. The grain was carried up to the feed plant, a large open-plan area at 7th floor level, directly above the silos, with a system of 3 horizontal ducts which dropped grain or foodstuffs into the 11 vertical silos. In the 2 uppermost floors was the top of the grain elevator and other electrically powered machinery. Although most of the machinery had been removed, evidence of former processes survived in the form of various conveyors, chutes, plant bases, overhead tracts, and a freestanding conical silo. Among the chutes was a curved S-shaped duct which appears to have been to pass boxed and packaged goods between floors. Among the interesting features of the building were a pair of continuous belt lifts for people to grab hold of and be carried up and down the building through holes in the floor. The belts incorporated a simple bracket to stand on and funnels at each floor to stop things catching. The belt lift is shown here in the image on the left. The main offices were located in the lower range adjoining the mill, and this was also constructed with mushroom-shaped columns. This area had a modest level of decoration despite its higher status, although there was an attractive staircase and inlaid flooring. These areas had been refurbished in the later 20th or early 21st century, but evidence of the original decor was exposed, and this had the character of a mid-20th century American office block with checker lino floor tiles. In the 1960s, the use of road transport by lorry greatly increased, initially alongside rail, but by the later 1970s or 1980s, the distribution was entirely by road. The rail facilities were removed, and the site saw a major investment at this time with the construction of a new lorry loading facility, as well as large new storehouse and office block. The covered canal wharf was also rendered redundant at this time. The factory ceased production in 2016, and in 2019, planning permission was granted for the demolition of the building and the redevelopment of the site. The building was not listed, but it was recognised in the local plan as being of some local interest, so a condition was attached to the permission for a programme of building recording. The recording was commissioned through CGMS, part of RBS, and it was undertaken at level 2. It included a detailed photographic survey, internal and external, and the annotation of existing survey drawings, plans and elevations, to document the building and explain it in terms of its history, evolution, construction and use. The approach to recording a large 20th century factory, such as the Honeymunster factory, is inevitably different to that of recording an earlier industrial structure. This is partly due to the sheer size of the complex. A detailed photographic survey can rapidly capture much of the essential information without the need for the type of traditional hand-drawn scaled drawings which would be appropriate for an earlier structure. In addition, the archaeological evidence left may be less indicative of the nature of the former mass production assembly line processes at such a factory. Records of machinery and original architect's drawings may sometimes survive, but they do not from the Honeymunster factory, unless they are in the Quaker Oats archive in America. When recording 20th century complexes such as the Quaker Oats factory, there may be greater avenues to record the social history side of the site, possibly through oral history. As previously mentioned, an excellent set of photographs were found on site at the Honeymunster factory, and some of these show groups of staff and social events. I will now hand back to the chair. Thank you.
Hello, well, thank you all for those fascinating talks. We're now live and the remainder of the session will be recorded and added to the talks for release on YouTube. So please do get your questions coming through the question and answer function, and your questions will be fielded by Maria Bellissimo, so thank you to her for that. And I think that's enough for me. I will hand over to Julian to make a start on the discussion. Thank you.
Well, I'm very, very worried, John. How on earth can you fill an entire building with making oats and puffed wheat? What on earth did they do on those huge floors?
Yes, there were an awful lot of pulleys, kind of conveyors, and they must have made an awful lot. I think there were several floors which basically would have gone over to processing and packaging. So yes, and they obviously needed further space. They were expanding, throughout the 1950s. So they grew and grew. Yes, interesting building.
You wonder then, almost finding quite a humane space if there's a lot of people working in these vast places, putting things into packets.
Yes, so, I'm sure that in contrast with some of the 19th century mills, it would have been a much nicer place to work. I would have thought in some ways.
And yet the room full of desks looked absolutely dire.
Yes, row after row, the offices.
Yeah. Richard, something I was prompted immediately by what you said. The sort of social and political comment on these buildings. Yeah. I mean, clearly that's, there's a Marxist view, and presumably Marx and Engels were talking about it at first hand. Yeah. I mean, did the political comment go with them almost from the very beginning?
Well, yeah, I think they're obviously fundamental to Marx's writings, and Engels, who was actually the son of a mill owner. He lived in Manchester. I think really because they are they do represent the first manifestation, really, of capitalism, which is why there was such interest to the likes of Marx, because they could see the processes happening in front of their eyes, you know, which so they're very, I mean, they're significant for creating that narrative itself, you know, which is obviously the counterpoint to the sort of the capitalism, the rise of capitalism. That's the counterpoint to it, isn't it? Because they're seeing that happen and they're living it. And you know, I suppose some people might say, well, they were probably privileged people themselves, which of course they were. But you know, they were. You know, it actually gave me an opportunity to reread Marx's Capital before I did this, which is, I must say, I think Marx himself said, don't bother with the first 9 chapters because they're absolutely, you know, it is obscure economic theory, and it's quite difficult to get your head around. But when you hit, you know, some of my favourites, you know, of that is you know, the working day. When you read that part of it, and the bit about technology, and it's actually, you know, it's so pertinent to what we're actually going through at the moment. It still has such resonance, you know. The processes they're describing there to do with mills, but it seems to still be pertinent, and that's quite worrying in itself. We don't seem to have, we're still wrestling with those issues and things that were created. And you know, once that system, problem is, once it gets created, it's very hard. You can't get out of it, can you? It's like the steam engine that you start up and you can't stop it. It keeps turning and rolling, and it's very hard to break out of that. But I don't want to go on here about, you know, a political diatribe and my own preferences of how that. But I see them as interesting. That's why I see they're so important as well, because they're a reminder to us of how the systems that we live in today have been created. You know, that is the importance for me for those buildings there. And, you know, not just that, oh, they made some cotton goods in them. Well, they did, but that isn't really, you know, now we should look at them, you know, for what they are, and they are the beginning of that process, and they've led to where we are now, you know. Anyway.
One of the curious things is that obviously at one level they were providing secure jobs from 7 in the morning till 7 at night.
Well, I think if you read Marx, the working day chapter that I've just mentioned, you might find that secure job and those working hours were absolutely awful. Now,
yeah, of course, there's but that plus
they manipulated labour to the max.
Yeah.
Now, what happened in the 1830s? You do get the factory laws come in, you know, from about 1835, which were attempts to curtail that exploitation of that labour. But what happens is, I think in Manchester at least, what the mill owners start to do is they do like weird shift working, where it's really hard for the factory inspectors to come in and determine what actually what hours people are working, you know. And so it's not really until later in the 19th century that those sort, you know, they sort of regulate that thing. So initially, I mean, the working hours are absolutely horrible, and you know, they exploited, you know, children, you know, quite young as well. You know, early on. I mean, again, you know, they're sort of, you can see them as, you know, this is the most wonderful thing that happened because it created our lives in a way, or the worst thing that ever happened to us as well. Because this put us in a situation of where we are today. I'm not blaming it all on the mill owners, of course, but you know, it's part of that. It's all part of that process of
And of course, housing is another area, though we didn't go into that with
Well, that's a whole different. That could be another seminar in itself.
because even a back-to-back
I mean,
house might be.
I mean, Ian will know, and the amount of workers' housing that we've dug now in Manchester and the region is phenomenal, and we've probably got I think from Manchester we've probably got like the best data set of late 18th, early 19th century housing, connected with the growth of one of the first industrial cities, which is an amazing thing. Ian,
do you want to comment on that?
Any thoughts on that?
I have. Yeah, not. Oh, yes, right. Some very interesting thoughts there, Richard. Some very interesting thoughts.
That's right.
I don't blame the textile industry completely, though, and I do think Mark's kind of bigs it up a little bit. I mean, I think there is a case to say that the whole system you're describing, in terms of capitalism, I feel that actually existed before, possibly related to the textile industry. But when you think of the domestic industry of the 16th even, but certainly the 17th and early 18th century, with textile masters, cloth merchants. That really was very much. I think they embody capitalism quite, to a great degree. But I think what the factory did, I mean, that's on a grand scale, isn't it? But I think it created, in the context of Manchester, it created more than just that system. It created society, as we know today. It forced all these people. Well, it didn't force it. It ended up with all these people coming together in one huge mass that was unprecedented. And it took a while to catch up, but 20, 30 years after the peak of this, it was really recognised that we got to provide a lot of social infrastructure. We've got to do schools. We've got to do some sort of health, etc., 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 and of course the housing.
I mean
Manchester,
probably
Manchester's a difficult one, isn't it? Really, when we talk about exploitation of certainly textile workers, because I mean locally they were known as the barefoot aristocrats, particularly the mule spinners, on account of their elevated wages compared to the rest of the working population.
Well, it's probably a matter of perspective, isn't it? But
it is certainly a matter of perspective. It is. Sorry, I always bristle a little bit when I read reports, and there is Engels again.
I mean, I'm probably being a bit contrary with it, but I think it does. I think with the mills, capitalism's got a long gestation. I'm not saying it was invented with that. But what we see here is how it absolutely accelerates, just because by that adoption of that technology, it sucks it in. There's a two-way process. It's actually feeding back into it. It's it sort of wraps up in itself, and it sort of gets a speed up, just like the rotive beam engine. Once it gets going, it's smooth energy, and it increases, and you see that in that technology. You see how it goes out of it's sort of out of control. It's sort of it's but like you say, Manchester was phenomenal as well, because it's also the place where actually the sort of fight against that system happened as well. And very much through the sort of the Unitarians community in Manchester, who were the enlightened liberals who invented all our liberal views of today as well. So we owe that a lot as well.
I always enjoyed is it Lord Ashton in Lancaster, who was a great philanthropist, supplying all sorts of things for his workers until the point they all voted against him. He's extremely grumpy, having done so much for them. They were ungrateful enough to vote Labour or whatever it was they.
That sort of thing. Yeah.
But Deirdre, one of the interesting things about your electric works is, of course, there can't have been many workers there. Do you have an idea of the sort of numbers employed?
I don't. Like, a lot of the photographs that I've seen, like those photographs of the plant. Now that might just be, photographs taken by the Engineer magazine.
Yeah.
But you don't see many workers in the photographs. You know, you see if you know that original photo with people outside. I don't know if you saw in the first elevation or the first photograph. There's men standing on the plinth.
No, that's right. Yes.
About 5 or 6 of them and they could have been the whole workforce having their photograph taken for the Engineer magazine. But yeah, there seems to be kind of not many people in the photographs.
Because it struck me a bit like Battersea Power Station later on, and like earlier breweries, you have these buildings with huge spaces inside them.
Yeah.
Just because either they've got steam engines or they've got generators, and
yeah, I mean, it could have been just a case of them coming in, turning on the engines, and the engines chugging away.
And yet, if you walk past it, you'd just like Lucy's ironworks up the canal. You'd walk past it and think it was a large factory area teeming with workers.
I mean, it did have very large open floor space, but obviously a lot of that plant is just gone now. But yeah, from the outside, when you walk past it, well, it's been completely redeveloped now, but from the outside, it looks like an absolutely huge complex. The most subdivided bit is the bit on the north side where there was like little subdivided offices and workers' facilities, a little cafeteria and things like that. The rest of it before the engineering department came in was just cavernous spaces.
Yeah. Because it's interesting. I mean, John much earlier looked at a country house generating plant at Clifton, where they'd simply lifted up the engines and all the bases were there. And you didn't have that evidence at Osney.
No, and unfortunately, it wasn't in our remit to go back in when they started digging into the ground. That would have been really interesting to see what the relationship with the river was, which we just didn't get a chance to investigate, unfortunately.
There are descriptions of it having water cooling, but we never. But Ian, I mean, in how many of the sort of mills and factories do you actually have the marks on the floor where the machines were, or the survival of the drive shafts?
In standing buildings, it's generally always there if you look hard enough.
Right.
Not extensively, but there's always usually there's indications of it, from bearing boxes, etc. Different phases in walls.
Yeah.
I mean, as you all know, a building is a book. It's just a matter of being able to read the language, isn't it, of the fabric? But no, you do get evidence for it, the best evidence is underground, often.
Yeah.
For me, because I find certainly some of the sites Richard presented, Shudo Mill in particular, is great because it encapsulates a real leap of technological development, essentially from a water wheel to a steam assisted water wheel to full steam power.
Yeah.
All effectively within 8 years, and it's the actual excavation to find that out, because any vestiges of 18th century material, certainly in Lancashire, is not visible to naked eye above ground these days.
Are there still many mills there, just waiting to be converted and waiting to be explored? Or
yes, I wish. This is something really, I don't know what baffles me, but it is a problem. As Richard rightly said, the mills in Manchester city centre, we see Murray's Mills adjacent, that's McConnell Kennedy, just down the way, Brownsfield Mill. All of those have been very successfully converted to very desirable residences, apartments. I forget what the penthouse at Murray's is, but I think it's going for 1.2 million, maybe.
They've been very successful.
Hugely desirable. And yet, desirable. 6 miles down the road in Oldham, persuade anybody to convert one of their derelict textile mills into apartments is unheard of. And this is a real problem in terms of the historic environment. Now, what you do with these monuments, because residential conversion is probably the optimum reuse for many, but it has to be in the right area for it to be successful.
And is everyone then paying for the preservation of a chimney into eternity?
Possibly. But again, very, 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 very landmark features. I mean, again, it's what Richard mentioned, they really are the iconic feature, aren't they?
Yeah.
And there's preciously few in the city centre of Manchester and Salford. Actually, in Greater Manchester, being honest.
I suppose you've just got the ones in Ancoats, haven't you? And you've got the ones by the Medlock. student halls.
Yeah, there's a classic in Miles Platting, isn't there, at Victoria Mills? A very, very, very ornate one. But yeah, very few.
I think Fred Dibnah knocked most of them down, so I blame him.
And then had the audacity to make a fortune bleating on about how great heritage is on TV.
Yes.
Yeah, it's kind of ironic, really. But, actually, I must say I'm really fascinated by both the Daylight Factory and the Osney Power Station talks. They're absolutely superb pieces of work you've been doing. Can I ask, just out of interest, have they been published at all? Is there any desire to publish those? If not,
just client reports. Yeah, nothing more than that at the moment, and I don't think there's really any aspiration. But I think certainly with Osney,
yeah, I think there's a lot of
ought to be
potential there. I think I think people in Oxford just aren't aware of how interesting it is, both its use as a power station and its use by Oxford University. I mean, its connections to NASA and the Mars probe, you know, parts of those parts of its history. I think and how much of that archaeology was still left in there when I got a chance to go inside was amazing. Yeah, I think I think it has a lot of potential for it.
Oh, definitely. I can speak with authority in saying Industrial Archaeology Review would tear your hand off if you just gave them the presentation and the script. It's certainly
Well, that's an idea. Yeah.
But yeah, great presentation. Thank you.
Thank you.
Of course, it also we'll certainly see with the Osney Mill and the work of the engineering department, a lot of those people are still alive. So there's the issue of, do you track people down and interview?
Yeah, it's like I said, we didn't get a lot of time or money for the investigation, unfortunately.
Yeah.
There's still loads of potential there. Sadly, the building is undergoing huge redevelopment at the moment, so the actual archaeology itself, we gleaned as much as we could, but there's definitely huge potential for a lot more historical research in it. And yeah, like you said, there's going to be people alive in Oxford who were there when the wind tunnel was in use. Yeah, it does have potential.
I mean, I do have an issue about some of the, it's wonderful to be asked to do some recording work, but recording isn't everything, and level 2 isn't everything, and there's really not an appreciation of just how, like an excavation, how much extra work there is to do, apart from walking around with a camera and marking up a plan.
Yeah, we were really lucky with Osney with the amount of material that was in the engineering department.
Yeah.
So many, and in Oxford Town Hall with the plans and elevations that they had in there.
With Osney, I think they've basically kept the facade, haven't they? But not much else. Is that it? Or?
Yeah, so it's basically been subject to facade retention. A lot of a lot of what in the inside has just basically been scooped out to a shell. I think the south side that was mainly buildings between 1927 and the 60s maybe, I think they're all gone now. And yeah, they've built upwards. And it was part of what I talked about in my impact assessment, the impact on the character of the building, because they have kind of, besides one atrium, they've basically honeycombed the building with like small rooms everywhere. And that obviously has an enormous impact on the character of the building. I think it's being turned in, Said Business School is turning it into an executive education center. I'm not quite sure what goes on there, but that's that's what it will be.
But to be fair, presumably some of these changes actually started in the 1960s when it closed.
Yes, so but what? So yeah, it was subdivided towards the south end for storage for the various museums. But a lot of what Oxford University, they did subdivide it with breeze blocks a bit at the south end, but a lot of what they did was kind of freestanding prefabricated labs.
Right. Yeah.
Yeah.
I mean, the other angle, I suppose, when one talks about the sort of this machinery and the dangers and stuff, is what sort of information one could get from either factory inspection reports or accident reports or journalism revealing the horrors of factory life. Or, and I know, you see, that with the things like the power stations, you've got the technical journals reporting what's happening. But I just wonder about the other stuff with factories and mills.
Yeah, I mean, anything. I mean, as you did with Osney, anything post 1890, you've always got that possibility of having building control plans, architects' plans.
Yeah,
a plethora of stuff in archives, isn't there? And all the oral stuff. And that's one of the things I really love and sometimes loathe a little bit about looking at industrial sites, certainly from the later 19th century onwards. It's just the mass of evidence that is actually out there if you can have the time to go and find it, talk to it, and locate it. You know, I mean, that for me, that's another big thing about the textile industry in Lancashire, and we're probably too late now. But capturing all the oral evidence that was certainly around in the 1990s, early 2000s, you know, from first-hand eyewitness accounts. And I mean, a lot of that is on the web, but I do think we might have missed a bit of an opportunity there. And maybe that's something that's, I don't know, maybe there is almost a research project in that with some of the later stuff, like we're talking about the power station and its later adoption by the university. Capture this information while it's about.
Yeah.
Sorry, that went on a tangent a bit. Sorry.
But that also brings us back to the commission and whether you're actually commissioned to do the historical work and the oral history, or just expected to sort of push that together and mainly produce a report based on your photographs and walk around.
It's very difficult to cost that up when you're doing a commercial project, but the MPPF does make this real big play for public benefit.
Yes.
And I wonder whether a lot more of the projects we do, and I know there's a lot of challenges, shouldn't try and engage a little bit more some of that local amateur expertise, local societies, etc., or specialist interest groups who really have a fantastic knowledge about old industries. And that can shortcut a lot of the expense would otherwise be required trying to gather that from independent sources. We've seen a lot of success doing that in Manchester, I must say, on some sites, although there are challenges in getting people onto active construction sites. I fully appreciate that.
Well, I talked to a small audience the other day about some of this, and there were two people in the audience who knew all about batteries and accumulator houses. So,
you can get quite a niche interest in things like engines and the horsepower of things, and which is sort of beyond me in a way.
Well, that's kind of a good thing. I mean, as archaeologists, we have to explore so many different, well, particularly industrial archaeology. You know, the range of topics that are endless. You know, we cannot be expected to kind of any sort of understanding of a lot of that. But we're more facilitators, aren't we? In actually drawing together all that information from whatever. I think that's
I was a little bit worried I'd get some questions about the Mars probe because I don't know anything about it.
Oh, why not?
But I know that John and his military work has been hugely helped by world's experts on airfields and aircraft hangars and.
Yes, clearly that's the kind of thing that, you know, we might not know. So sharing in that kind of expertise is obviously invaluable at airfields and such things.
That's another interesting point, you see, because everyone assumes that us poor archaeologists have to go to the universities to tell us about Anglo-Saxons or Romans. And the wonderful thing about industrial archaeology, there's probably 3.5 people in universities, and the experts are all the people out there who actually know more than all of us. Because they've got some niche interest or they've spent their life, you know, looking at this or that. So
that's very, very true.
Inclusive kind of subject.
There's a lot of very well-informed people out there in the field of industrial archaeology. You know, and as I think Ian says, I think our role really is to try and synthesize that and and engage with those people as well. It's really important because they have got a really good body of knowledge, and which can really add to what we do. And we can't have the bandwidth to actually know all of this. That's the thing.
Yeah.
And a lot of it's in their heads as well.
Yeah.
It's not written down anywhere either. You need to speak with them.
I mean, at the end of the day, really, our remit as archaeologists is to disseminate that information, isn't it, as widely as possible. Any information we're finding out from particular sites.
Yeah.
It's not knowledge exchange. I mean, that's our raison d'etre, surely.
Very well said.
That we must do. And just going back to the sort of building question, and Ian, you did mention the cottage industry, and I've been looking a bit recently at stocking knitting around Kendal, where clearly there are people turning up and knocking on your door and saying, "How many have you done this week?" And we all know that sort of vernacular level of, weaving lofts in cottages. Which must have been quite prevalent in some areas where later there are mills. So almost one of the most extraordinary things about Arkwright is he builds this sort of fully formed multi-story mill. I mean, is that really so? That it sort of starts off with a multi-story building. There's not a sort of...
Well, I think Ian, correct me if I'm wrong, they sort of come out of silk mills, don't they, these things?
Right.
In the sort of early 18th century.
Yeah.
I think the Lom brothers or someone like that. Is that them?
Yeah, in
Derby.
Yeah.
They sort of invent the building, if you like.
Yeah.
But the sort of technology is then invented by, it's Arkwright, isn't it? Because he invents the water frame or whatever. So that's
just suddenly having a sort of multi-story practical building.
Yeah. I don't know. I mean, I'm not sure whether I might be imagining this. Are there some very early ones in Italy or somewhere like that? Is that where and of course, what we mustn't forget as well, there is actually really, I think there's comparable sort of rises in the textile industry in other parts of Europe. If you go to Barcelona or places like that, they've got a really early cotton spinning as well, I think. I might be wrong, or there's some early textile. But obviously, not speaking Catalan, don't really know a lot about that.
I think there is another aspect actually to Arkwright's mill in Manchester, specifically his Manchester one. As you said, it was the largest one he'd ever built. I think what he didn't shout about is that he didn't actually fill it with machinery for 7 years because that machinery just wasn't available more than anything.
Yeah.
And one of the principal reasons he probably built it so large is to put it into the face of the traditional Manchester manufacturers, to basically say, you guys have been contesting my patents, you've been trying to bankrupt me, but I'm here and I'm as wealthy as hell, and here's this building to prove it. It's quite interesting because the mill's actually on a bit of a rise overlooking the Irk Valley. And I remember an artist friend of mine, he went to come and have a look at the site. And it's really interesting talking to him because he has a slightly different perspective on everything we do. So we do engage quite a lot with archaeology. And he turns up there and I said, right, well, this is Arkwright's mill. It was 220 foot long. It was 5 stories high. He goes, so Arkwright had built himself a castle on the hill just to annoy the merchants. And I think
that's right.
On the head. It was unnecessarily large in that particular case.
So that's sort of symbol of power.
It's a symbol of power, but it's also, I think, a symbol of the emergence of the new manufacturing classes as a very powerful force in what was an established society. So again, we are coming back to that capitalism thing you were talking.
We are, aren't we? How there's a transfer of power.
I think it's dribbling down to a rising middle class rather than the upper class elite that it always had been, who effectively, were capitalists in their own right.
It's just as you say, rise of the bourgeoisie. It's just that the money is going into that. I mean, I think in Manchester, you probably had that a bit before as well. You've got quite wealthy families engaged in the sort of fustian industry and stuff like that. So the sort of circumstances were all right. They all came together in Manchester. It was correct for all of this, which is why I find it a very exciting place to be. I mean, I unashamedly, I love the city. I think, you know, I do live here. That's you know, and I think it's a very amazing, fascinating place for seeing these processes, and it's almost circumstances as well. It was all right. All the right pieces were there, and they all slotted into place at the correct time, and bam, you know, you've got suddenly a massive city suddenly appears out of this, spewed out of the ground almost. Amazing.
What I do find fascinating about the city, one of the things I find fascinating as well, is that as part of that process, it became a pool or a magnet, really, for really incredible engineering talent from all over the country, particularly Scotland, quite a few from Wales, driven to Manchester, really, to, I suppose, really, to make their fortunes in the capitalist system that was surrounding the textile industry and the ancillary industries as well. I think that's important, because it wasn't really only just textiles, because that spawned a huge variety of different types of industry that supported it. Who's making all the machinery? Who's making all the bricks? Who's making all the structural ironwork to go in these mills, etc., etc., etc.
Well, as I say, there was, well, of course, there's a massive ironworks in Manchester, and you've got Bateman and Sherratt making engines. You've got, like, you know, you've got, like you say, an influx of brainy Scottish people who like to go to Ancoats and make mills there and do things, you know. So it was like a big magnet. I mean, I hate to say it as well, coming from living in Manchester, you know, obviously Liverpool's quite important as well to this process.
It was a symbiotic relationship. It wouldn't have happened without Liverpool.
It was an absolutely symbiotic relationship. But, you know, that was the port, the route that everything came in and went out, and the rise of that city as well is fascinating. But obviously, I haven't got time to even ponder on that now.
And then, of course, having made all their wicked millions, the new money goes out to the country, and they build country houses. Some of them
do, yeah. I mean, in Manchester, I think initially it's in sort of place called Victoria Park and around there, isn't it? And Ardwick. They're the initial places of the rich, and then they gradually start moving further out. You know, I mean, ironically, you know, I live next to one of the first suburbs as well. You know, it's a place called Whalley Range, and that's a very early suburb built for rich people who didn't want to live in that mess of Manchester, which ironically became, you know, a really run-down area and very undesirable. But now, through the process of gentrification, has now become back to its original purpose again of being a home for the rich people. And now you can buy a house for about £1 million or something like that in Whalley Range. Amazing.
Yes, I suppose you do get sort of leapfrog movements from town centre.
It runs everything. All of this just runs in cycles. You know, it's sort of you know. I think that's what's happening in Manchester now. It's, you know, 30, 40 years ago, the city centre was dead. It was like a ghost town. There was no population there. Now you go there, and every bit of space is being developed, exploited. Mills, towers, you know, it's and actually to watch that city now develop is again incredible. A process that's happening there now. You know, it's amazing. They're making a city in front of me. You know, so exciting times as well for that sort of thing.
It's something that does strike me every now and again, actually, and it was absolutely brilliant working with OA during those early 2000s, because, well, looking back now, you can walk around Manchester and it's, oh yeah, we had a significant input into that site. We had a significant input into that site. Oh, we're significant. Every single tower, you know, we've really been, I feel like we as a group have been really at the forefront of this real renaissance and rebuilding of the city.
Yeah.
You know, it's going to be painful to look back in 50 years as, you know, crucial period in Manchester's
Oh,
very
yeah,
long
definitely.
history.
Yeah. Well, it's good to be. I'm happy to have been a small part of it myself. You know, because it's been exciting, and you know, and I think, you know, OA had done, when you were with us, he done some fantastic projects. You know, and you know, the great thing is that you've kept this. You know, I know you're in passion for all of that as well, and it's amazing to see that translate into what you do as well, which is great, you know. So thanks to you.
You don't quite have what we have in Oxford, where those of us who had fun digging on medieval sites 40 years ago see the buildings coming down, and we have a second opportunity to dig the site. Wonderful. See a multi-story car park come down, and we dig up the stuff we didn't get in the 60s.
One of our big problems in the north is that when all these mills, textile mills, factories, ironworks, etc., massive tracts of workers' housing with cellars were erected, all the medieval archaeology got put on the spoil heap. We just rarely find that in the city centre these days, which is a little bit frustrating, but
yeah,
small price to pay, I think.
Well, yeah, there's little islands of it floating around in between areas of storage, and when they punch through it, you might find a small patch. I remember
Roman Manchester
in the
too.
centre, we found a one like a metre square of medieval archaeology sandwiched between a cellar. It was amazing.
I thought Manchester was a Roman place in origin.
Oh, Rich has found loads of fantastic Roman gear around Castlefield.
Yeah, I did a lot of the excavations on the Roman stuff in Manchester. Again, that was, you know, that's pretty disrupted by the industrial remains, but there's quite good patches of it left there. So
yeah.
Yeah.
John, I want to come back to. So I do want to come back to puffed wheat. I just love this bit. There's all this daylight in this building, and tubes running through the building, sort of with sort of shreddies and puffed wheat flying this way and that.
And dog food.
I just wonder how appropriate the daylight factory actually may have been for that process.
Yes, exactly.
Or whether it's just a cheap way of building a factory, giving you the space.
Yeah, I mean, I don't really know how cheap it actually was. I imagine it actually would have been cheaper building a single story shed. But I think that there was an American company that owned the factory, and maybe their idea of a factory was a great big multi-story thing. So I think it did kind of follow the house style of Quaker Oats. So it is similar to the ones in America. So I suspect that was part of it, but it would be interesting to find the original plans. There must be some somewhere, but we haven't found any in this country anyway.
Yeah. No, because obviously if you've got lots and lots of people, it's much better having huge windows and space than.
Yeah, as I say, the kind of benefits of a daylight factory in terms of having lots of natural light, it was getting less and less by the 1930s. With electric lighting, it was less crucial, really. And I'm sure that sometimes they had too much, direct sunlight. They probably didn't want to have quite that much sometimes.
Yeah.
I think the vertical integration probably got a real issue as well, isn't it? If you're producing, well, I'm thinking really the motor industry. I think it was the Dennis factory, the Dennis company invested in a daylight factory, didn't they? And they began to struggle big style with actually moving assembled vehicles between the floors, even though they
up and down,
up and down, slow and inefficient operation. I mean, motor industry is very, very specific, and you are dealing with very large items. Well, and that's certainly one of the issues they experienced, I'm sure.
But the most extraordinary thing there is that, well, for example, when Morris moved from his small assembly works to the old military college, he had the cars moving around the building, which sounded very innovatory. But then I discovered that in London, in the Covent Garden carriage works, in the 18th and 19th century, the carriages moved around the building from floor to floor and went upstairs and downstairs. So it wasn't invented by Ford. It actually went right back. So yeah, and obviously you've got people doing the wheels, you've got people doing the bodywork, you've got the painting, you've got the finishing. You know, for the same reason, you've got a whole lot of different processes which need to happen in different spaces. But I'd love to have seen one of these 18th century carriage works, whether they had a conveyor belt or just cranes at the end of each row that sent it up or down. But, of course, later on you get multi-story stables, don't you, with sort of ramps going up, which predate the multi-story garage by many, many years. Right. Well, I don't know if any of you have any other further comments. Deirdre, is there anything you want to come back with on what you wished you'd done at Osney or wished to do next?
Oh, well, I think there was a lot more that could have been done, and it was really good doing the presentation because it reminded me of just how good that project was, and actually how much more should be done on it. But
and we've also got gasworks, gasometers tucked
yeah,
under.
yeah.
We've spent a lot of time looking at those.
Oh, really?
Oh, sorry, time's running out, Ian. We'll come back another day with them.
Yes, we have looked at lots of gasworks. Yes, gas holders. So yeah, I'm sure we can do another one.
Ooh.
Can I just say, sorry, that's one of the reasons we wanted to do that we chose this topic for the seminar. Was to really showcase the work of the historic building recording team, and we're really conscious of that why we're not publishing more. I wanted to get the panel's view on that. I mean, is it what's stopping us really? I mean, obviously the money is a thing, but why aren't we being required to publish in the same way we are with other archaeological sites?
Oh, it's our colleagues' prejudice. They think it's not real archaeology, you see.
It's absolutely fascinating. I'm so sorry that my father's no longer with us. He was a nuclear physicist and he worked in a factory, an engineering factory, and he would have been absolutely fascinated by it. And as you say, there's so much scope for public interest and so much outreach we could do, so much community engagement, apart from the academic side of it, which is absolutely fascinating. So it does seem a wasted opportunity, really. And we do want to carry on with having building recording sessions. So I feel one on gas, whatever you call them, gas holders coming on. But we've talked about doing theatres, hospitals, asylums, all sorts of things.
We've done plenty of pubs.
A lot of people would engage with that. That would be a fantastic topic.
Have you done some lunatic asylums or something?
Oh yeah, I mean, I've been doing a lot of work at Broadmoor and just hospitals in general. We've done loads of hospitals, but Broadmoor is absolutely fascinating. Really.
So if you do have ideas for things you think we really should be doing, then do obviously let me know. We're no longer the previous seminars we've been doing were chronological, and we're now venturing out into other other things, other subjects. We just happen to have actually come full to the modern period with this one, following on from the post-medieval cemeteries one we did earlier, which in fact I don't know if any of you saw it, but they touched on some of these issues about people's the physical impact of working in factories and so on. I don't know if you've managed to see that, but I would recommend watching it on YouTube if you didn't actually see that. So, but if you do have any ideas, do please let me know, and we'll have some more seminars.
Good. Well, thank you, and thank you very much to all the participants with so many extraordinary and interesting things to say.
And I would also like to offer a big thank you to Danielle, who's behind the scenes doing all the technical side of things. So she's done a fantastic job. And again, thank you from me for what's been a fascinating session. Are we all ready to go off and have something to eat now, do we think?
Yeah.
And possibly drink.
I think off to get some coffee.
Just one final thing. I think Danielle will be in touch with the people who've watched us in the audience with some opportunities for feedback. We'd be very grateful for that.
Yes, and obviously if people have questions, they'll be forwarded to us and we'll hope to answer them.
Absolutely. Yes indeed.
Thank you all.
Great, many thanks.
Thanks for a very
Thank you very
enjoyable
much.
hour or so. Thank you.
Thank you.
Thank you. Yeah. Bye.